Good morning, ladies and gentlemen. Today we're going to go ahead and look at a histogram and box and whisker plots after they've already been created and look at the shapes of data distribution. So first we're going to look at the shape and then we're going to look at the specific different types of distribution. So there are four main shapes. The first is a normal distribution, and then a distribution that's skewed to the right, a distribution that's skewed to the left, and a U-shaped distribution. We're going to go ahead and start and take a look at normal. Normal is symmetrical, which means it's the same on both sides, and it's bell-shaped. So this is what it looks like on the bottom when we look at a normal distribution. It's a smooth curve with about the same. If we were to fold it in half, it would meet on either side. And this is what a box and whisker plot looks like with a normal distribution. We have a normal size box and both sides of the box are even, which means it's cut in half, and some normal size whiskers on either side. Now the highest point is the center, and of course that median line is the center of your box, in your box and whisker plot. And it's a mirror image on both sides, and the whiskers are approximately the same length. If we're going to analyze this data, the best use of the data is the mean. So we'd add them all up together and divide by the number of items in order to find that average of this distribution. Our next one is called skewed to the right. Now, skewed to the right is a little confusing, but skewed to the right, as you can tell from the picture, means that it has that long tail on the right-hand side, and most of the data is on the left. So skewed to the right means that the long, skinny part is on the right-hand side. And as you can see on the box and whisker plot, the box is towards the left-hand side. So most of the data, as you look at that, is on the left, and we have fewer data points on the right. So that means most of our answers are small. So our answers are 10, 15 in this case, and there's not as many with bigger numbers that are 60. And this is also called a positive skewing. And finally, if we were to find this out, we want to go ahead and find the average using the median because of the fact that we have such kind of almost outliers that are bigger. And so we want to go ahead and split those off to find those middle numbers instead of adding them all up. Now you can imagine if skewed right looks like this, skewed left looks the other side, where we have most of our data points on the right-hand side. Most of our numbers are going to be bigger. Our box and whisker plot, as you can tell, we have not straight in the middle for that box, but it's towards the right as well. So fewer data points on the left, most answers are larger. This is called a negative skewing. And we also use the median for this because the outliers. In this case, the outliers are the smaller numbers and most of our data are larger. Our last one is a U-shaped data. And as you can tell, it looks like a U, shockingly enough. And this has most of our data is in the box, and there's little tiny whiskers going off on either side. It is also symmetrical. We could fold this in half just like a normal bell curve. Our lowest point is in the center. So the least data points are in the middle, and most of our answers are on the right or left. Most of the answers are either really big or really small without a lot going on in the middle. And it's also, like you said, mirror images. And the box is large with small whiskers on either side. There's not really a good way to find the middle of this data because it's two clusters, basically. We have a lot of data that's really, really big and a lot of data that's really, really small. So there's not really a way to find that middle number. The middle number is actually the least occurring. So there's not a good sense of how to find that median, mean, or mode for the number. Now, the distribution, there's a couple weird quirks that can happen. The first is you can see a cluster in your data, and that's values that are kind of little groups that are away from the rest of the data. So if you take a look at this picture, you can see that 0, 1, and 2 here are a cluster of data, and they're away from the other pieces of information over there. You can also have a gap, and a gap is an area where there's no responses. So as you can see here, 3, 4, and 5 form a gap where we don't have any information. No one answered with a 3, a 4, or a 5. So we have a gap in our data. Then we have a peak. A peak is the highest point. A peak is our most frequent answer. It's our mode. And you can have more than one mode. You can have a single peak like we have here. You could have a double peak where you have two that are the same height in different places. And finally, outliers. As we know, an outlier is a number that's either really, really big or really, really small that doesn't fit the rest of the data. I always think of this as get outlier, you're lying, that it doesn't even make any sense. When we were talking about our number of pets, the outlier for that group would be the student who had 15 animals, 15 pets. We would say, wait, that doesn't, everyone has 1, 2, or 3 mostly for pets. You have 15? What? So that 15 doesn't fit the rest of the data normally. Our word of the day today, ladies and gentlemen, is coffee. Delicious. I hope you guys are all doing well. We're going to work on our Desmos project tomorrow and a quiz on the information that you learned this week on Friday. I hope everyone's doing great. See you soon.